Welcome everyone. This is our second tutorial on how to learn and program using Jello. This set of libraries are a toolkit that helps us develop programs and simulations for particle and medical physics. This is our second lesson, and today we're going to learn about basic user interface. My name is Gustavo Valdivieso. I'm a professor of physics at the Federal University in Brazil, and I do these tutorials mostly for my own students, but I do them in English this time instead of Portuguese, which is my native language, so I can reach a broader audience. Maybe you have the same learning issues that my students have, so you could benefit from these as well. If you have any questions by the end, please leave them on the comment section of this video or contact me through this email. User interface, what do we mean by that? Jello has a system called intercoms, which manages values between the run manager, which is the system that actually runs the simulation, and all of its components, so everything that happens inside the simulation, and the user, which means you. So when you run a simulation, the simulation expects a few commands, and these commands, they can be given to the simulation either through a text terminal, so we're going to text to type today, or through a graphic user interface, which is a topic for another day. Now, today, we are going to talk about two classes, the G4 UI Executive and the G4 UI Manager. The Executive is the first one, and this guy, it enables you to use the user interface and help you create the proper user interface. What do I mean by that? You have several options. Well, to be more precise, you have 5 options, 2 of them through terminal commands, 2 graphical user interfaces. Well, actually, this one also, it uses a graphical system, but it's also a terminal of sorts, and one specifically for those who use Windows, Microsoft Windows. Today we're going to see these ones. They are the same. They are visually the same. It's just different systems. The TC shell is more modern, and the C shell is an older version which is included into the TC shell. So if you always use this one, you're fine. In our code, you're going to see something like this. We're going to create an UI executive object from this class, from the G4 UI Executive class, and we are going to pass to it the 2 main arguments that any C++ program has, which is the argument count and the argument vector. These are variables created together with the operational system that passes parameters to any program. We're going to implement those in our own programs in a moment. And here you can type one of these strings to create the type of session or the type of user interface you want. After that, you just have to say to the executive to start a session, so session start, and when you're done, delete this object. Now, the UI manager, this is different. This guy, it actually manages the commands. So how each command, like this one in text over here, and the main ones that we're going to see today, how they transfer information from your hands, from your typing, or from a macro file, we're going to see those today either, and how they transfer information from them to the system, to your simulation. They are thread local singletons. Again, this is very technical, but it's a way to tell you that this guy always exists, and I said in plural, these guys, because they are thread local, which means for every CPU that you have running, and you have a worker thread sharing the load, sharing the simulation in any one of those CPUs, each one of those is going to have a copy of this guy, because commands have to be relayed to each worker node, to each thread. How does this work? You tell this pointer, you tell the UI manager to apply a command like this one. Remember in our first tutorial where we said beam on and shot like 1,000 particles. Now you can do the same, but through a command. And you can apply other types of commands like this one, the control execute, and we're going to see how we can get a parameter from the command line and pass through the UI manager, making our simulation execute a file full of commands, which we call a macro file. Let's dive into the code, and we're going to do this together. We're going to start from exactly the same point where we left in our first tutorial. So this is tutorial 001, but I have copied it to another place and renamed it 002, just so I don't destroy the old one. The first thing we're going to do is include a few more headers. So the user interface. Let's do them in order. So the first one we're going to include is the G4 UI executive. And we are going to create an executive here. So first, let's remove the beam on from the manager, right? And just after the initialization of the manager, we are going to create our own executive. So, UI executive, new G4 UI executive. And here, we need to pass a few arguments. We need to pass how many arguments, so arguments count, how many arguments our program have from the command line, a vector of arguments, so argument vector, and a type of session, which could be the C shell, as I mentioned before. And these guys, they don't exist yet. Why? Because we didn't implement them. So come here to your main, the entry point. This is called an entry point. The operational system always starts your program through this point. And it's going to pass to your program any information from the command line. The first one is the argument count. So how many arguments the user passed on to your program. And the next one is made of characters, and it's a vector of characters called argument vector. You can name these whatever you want, but these names are very standard. And there you go. Now we have our executive, right? And all we need to do is say UI executive start session, or session start, I should say. There you go. When everything is said and done, we delete our UI executive, because for every new, there has to be a delete. Okay, that's it for now. Let's open a terminal, remake, and now make. Okay, let's go into it. Tutorial. As you can see, this time we stopped at a different place. Remember, last time we got to this message and we only passed over it when we said beam on. But now we have a prompt. We have a place we can type things. And it's telling us that we have available a few UI sessions. You probably will see only these two. These ones, they depend on how I compiled mine. If you follow my instructions and you compiled with Qt, you can see this one, but I didn't say how to compile with XM. But when we get to the graphical user interfaces, I will revise this and let you know if I have any tricks on how to do this. And we will get there when we get there, you know? So back to the command prompt, you can ls for list, and you see a series of subdirectories. See, these are like directories on your system, except they hold commands. So the first one, we can go to run. So if you type ls run, you see that run has several commands, lots of them actually. And the first one, or the second one, I should say, it's called beam on, and it starts a run. And this is what we did last time. So let's do this. Run beam on, 100. And there you go. Our simulation just works as before. Instead of having our manager being on over here, we just passed a command. This is the power of user interfaces, because over here, everything I type is encoded, it's hard coded. I can't change this unless I recompile my program. But now I can change whatever I want. But that's not true now, right? I would like to change the particles and the energy. See, we have a gun menu, but this was here a moment ago. Let me show you what I mean. If I go away and come back to the simulation, if we go back and I list, you see, there is no gun. What's going on? If we run beam on 1000 particles again, you see that after I run this, there is a gun menu. It only appears after I run. Why is this happening? Well, I'll get to that, but how do I use this before we leave? You can list the gun menu, like this, and you see we can change, for instance, particle, energy, whatever we want. So let's do this. Let's do gun, particle, and change our particle to a proton. And now we can run again. And see? Electron. Why can't I change this? Well, actually, I can't change this because I have it defined in here. And now, I want to be able to change it. I want the gun command to exist from the beginning, and I don't want to fixate my particle. I want to be able to change it at will through commands, right? So let's fix this. In our last simulation, oh yeah, by the way, in order to exit the terminal, the prompt, just type exit like this, and you'll go back to your operational system. Okay, so go back to your generate primary action. Remember when we generated the particle gun, right? So this is created when we ask for a new primary. That's why the gun menu wasn't there at first, but after we run a few particles, we had a particle gun. But also, we have it to have a single definition, and every time I run it, it recreates the particle gun with the same particle. So we have to remove this first. And look, I didn't say this before because it was our first tutorial, but this isn't the best way of doing this, on how to do this. Okay, take a look. On our primary generator, we're going to create a private section, and here we are going to create a member function, actually a member data class. So get the type particle gun, and from this type we're going to create a pointer called m particle gun. What does this m stand for? It means member, meaning that this is a data member. This contains data, and it's part of my generator. So this guy is only going to be destroyed when I want. And I don't want it to be created every time I order new particles. I want it to be created only once. So I have to take this creation part out of the generate primaries method. In order to do that, we need two things that every C++ class has: constructor and destructor. So get the same name like this, and you open and close brackets like this. Now you can copy and do the same again, but with a tilde sign at the beginning. This is a constructor, this is a destructor. Now, just below your class, you can paste this again, but now remember to put the same name of the class before with colon, and open the curly braces like so. Now we will do the same, but with a tilde over here, like so, right? So in this one, we are going to create our particle gun. So we can remove this from here, paste it here. We don't need the auto because this variable already exists. We just need to change the name that we used before in particle gun. See, it's the same one. And when our generator gets destroyed by the simulation, we need to delete the particle gun. Remember, for every new, there has to be a delete. Now, when we order a new primary particle, yes, now we are going to generate it like this. And I don't have to set anything, not even the type of particle. I will simplify this a little bit. I will remove the event ID and only leave information about the particle definition and the particle energy, like so. Okay, let's compile again, make. Out of curiosity, you don't have to see make every time, only once. Then you just use make and make the text only what changed and recompile only what's needed. Tutorial. And let's see what changed. Let's list, and you're going to see the gun over there from the beginning. We can already type gun, particle, and let's say proton. There you go, you have a proton. And now run, beam on 1000 protons. See, now we change it to proton. And we can change anything else we want. We can change the energy, we can change the direction, the momentum. We can select other particles, etc. For instance, let's get gun energy and say 250 MeV. And let's generate a few less particles, like 100. There you go. See, now we can control our primary generator from outside. And there are so many interesting commands. We can see all the materials, all the units, the geometry. I encourage you to look into the Gen4 documentation and explore what each of these sub-commands, these subdirectories, what commands they have for you. For instance, there is a particle sub-command, so you can ls particles, like so. And there is a command named list, so I can do like this. Particle list. And you get a very organized, in alphabetical order, list of particles that you can use in your simulation. You can change that electron or the proton to any one of these particles. Okay? Oh, right. And I didn't show you what the default particle is, because I changed it to a proton just when we got in. But look, if we go out and back again, and I just say run beam on, let's say one particle. See, the name of the default particle is a Giantino. it's a play on neutrino, because neutrino almost doesn't interact with anything. And the Giantino is a fictional particle that literally doesn't interact with anything. It just flies through everything. So the simulator, Gen4, it tracks the particles, Giantino particles I mean, but it doesn't follow any physics. That's why it's interesting. This is it's a test particle, right? Okay, now let me show you how I can use commands from inside our program. That's where the UI manager comes in handy. So again, let's go to our main section. So, and include G4 UI manager. As I mentioned before, the UI manager is a singleton. So all I need is a pointer. UI manager G4 UI manager get UI pointer. So this guy is going to get a pointer to our session. But when I do this, I don't even need to have an executive, because the executive is the way I interact with the session. But take a look at it. The commands, remember the intercoms? They exist no matter what. So if I comment this out, and also this, because I can't delete something that doesn't exist. And just have the UI manager. Take a look at this. I can do UI manager, apply commands, right? And here I can type any of those commands. For instance, I can say run beam on. Okay, let's compile and run again. There you go. Except for the fact that now our default article is a Jantino instead of an Electron, this is the same program as our tutorial 1. Why? Because we just replaced the manager beam on line by the UI manager apply command beam on. So we changed one thing to the other, but it's all the same. But we can do better than this. We can actually ask it to run this from a file. So let's open our menu over here. I will create a run.mic from, this is a macro, right? But you can name it whatever you want, it doesn't matter. And over here, I want to do something like this. Gun, particle, proton. Gun, energy, 250 MeV. Run, beam on, 100 particles. Right? So I want to run this guy. It now exists here outside my build folder. Okay, so I'm going to copy this inside the build folder. And if I list here at the terminal, you can see that with my file, I have that run.mac. This is my macro file. Now come back here and change this to control execute run.mac. Let's compile and run again. And there we go. See? If we go back a little bit, not too much, you can see that it created the works for our task and just ran protons with 25 MeV on several workers until we have, how many of them? 100. Can we do better? I think we can, actually. Because as it is, the name of the file is hard-coded. I can't change this. So that's where these guys come in handy. Let's declare here, let's include actually a g4 string, which is a class for text, like this. And now I'm going to choose which one of these I want. So let me explain a little bit about the command line. When I type something like this, tutorial, the name of your program, this is considered the first parameter. So the argument count is 1 because there is one parameter. And the argument vector starts at 0. And the first argument, argument 0, is this word over here. It's just this. If I type something after this, for instance, if I type run.mac, now the run count is going to say 2 because I have 2 strings, 2 words, and the argument vector is going to contain element 0, which is tutorial, and element 1, which is the name of the file. I'm going to use this in order to help me decide what I am going to do here. So if the argument count is just 1, so if it's exactly 1, it's never going to be less than 1, it's never going to be 0 because it's always 1. The name of your program is always an argument, right? So if it's exactly 1, then it means that it doesn't have any parameter. You just type it tutorial or the name of your program. It has nothing after, because if it does have anything after, then this is not 1, this is 2, 3, 4, etc. So we can uncomment this and bring the delete over here, like so. And now, if I only have the name tutorial, I'm going to start a session so the user can type his or her own comments. Else, so if I have any other number of parameters, then I am going to get a pointer to my user interface, but I will get the next word here. For instance, run.mac. How do I do this? I create a div for string, file name, can name this whatever I want, and here I'm going to say argument vector, argv, argument vector, number 1, because vectors in C++ start from 0. So this is the word 0, this is argument 0, this is argument 1. I'm going to get only the first one. If I type more things over here, I don't care. I just care about the first one. And here I'm going to remove it, remove the name, and add a plus and say that it's this string plus file name. There. This is super useful and already very powerful. Let me show you. So first, let's recompile. Now, if I just launch tutorial, I should get the prompt, right? I will exit. Now, if I say run Mac, instead of getting a prompt, I will run my file. And that's it. This is the basic you have to know about user interface. On a next tutorial, a little bit later, not just the next one, the following one, but on a future tutorial, we are going to explore a little bit more about this. I'm going to teach you how to create your own messenger with your own commands, so you can personalize your command system. That's it. You can download this code from my GitHub as always, and if you have any questions, leave them in the comment section below. See you next time.